Hello, everyone. My name is Binoy Sarkar, and I am a senior research fellow at the University of South Australia. I am also a member of the executive committee of Clay Minerals Group of the Mineralogical Society of the UK and Ireland. And this Clay Minerals Group is one of the oldest working group of the Mineralogical Society, which was established in 1947. So over these many years, the Clay Minerals Group has contributed significantly to the advancement of clay science all over the world. The group celebrated its Jubilee anniversary, 75th year Jubilee anniversary in 2022. And as a part of activities during the Jubilee year, the group wanted to make a series of videos with clay scientists all over the world. And the aim of this video series was to highlight the diversity of great minds behind all the outstanding works about clay science around the world. And today, I am very glad to welcome and have an interview with Dr. Samar Datta, um, who is here with me. Hello, Dr. Datta. How are you today?
Hello.
Let me first introduce Dr. Datta to all of you. Dr. Samar Chandra Datta, he obtained his BSc Agriculture Honours degree from Bidhan Chandra Krishi Vishwavidyalaya in India. He also had his MSc and PhD in soil science and agricultural chemistry from the Indian Agricultural Research Institute, which is located in New Delhi. Dr. Datta published more than 100 peer-reviewed papers in national and international journals. He successfully supervised 15 PhD and many MSc students. He is the recipient of International Potash Institute Award, Indian Science Congress Award, and most importantly, he has got the Best Teacher Award from Indian Council of Agricultural Research, Indian Agricultural Research Institute. And I am very fortunate and very pleased to say that I have been one of the students of Dr. Datta when I myself did my master's degree in soil science at the Indian Agricultural Research Institute. Dr. Datta is also a fellow of Indian Society of Soil Science, a fellow of Clay Mineral Society of India, as well as the Society for Fertilizers and Environment. Dr. Datta worked for many years on various aspects of clay mineralogy, especially soil mineralogy, and his research focused on potassium and phosphate dynamics in soil, soil clay minerals crystallinity and particle sizes, clay organic complexes in soil, and he has also done some work on nanoclay polymer composites. One of the key achievement or contribution of Dr. Datta to the field of soil science and clay science is that he invented a digital soil test and fertilizer recommendation meter, which in short is called STFR meter. And this particular instrument he invented, patented, and has been now commercialized. And it is being used for routine soil test and a fertilizer recommendation job. And this is a technology which has been at the farmer's doorstep, and many Indian farmers are being benefited by this equipment, which is a very low cost instrument, and it can be used by purchased and used by everyone. So let me welcome Dr. Datta for this interview, and thank you, Dr. Datta, for agreeing and for your time for this interview. So let us start.
Okay, thank you.
Let us start by asking you how you have been introduced to the world of clay science, and especially soil clay mineralogy. So, what was the catalyst, and who was your motivator to enter into the world of clay science?
I was in BSc Agriculture. Preliminary, I had a knowledge of that, clay minerals, by my teachers. But the full interest grew when I came in the MSc Master's program. And there was one of my favorite teachers, Dr. B.K. Sharma. He was a lovely teacher and very efficient teacher, and which created interest in me for the clay minerals, their structures. And so it was so interesting that it was fascinating for me to study the clay minerals. And then I started working on clay minerals in my master's as well as in my PhD program. Later, although I worked on other fields also, soil science, but side by side, I also worked in the clay minerals.
Yes, and sir, you have coordinated a course on soil clay mineralogy at Indian Agricultural Research Institute for many years. So, would you please tell a little bit about that course, like how and when that course was developed, and what was your experience delivering that course at IARI?
Well, that course for clays and clay mineral was uh, when I studied in MSc and PhD, it was before that formulated by my teachers. Then after I joined there as a scientist and teacher, then I started teaching that course, soil clays and clay mineralogy. And there are some modifications which I introduced in that courses. It is basically the all aspects of clay, starting from the clay separation, clay purifications, and then processing the clay for X-ray diffraction, DTA analysis, and then regarding the any properties of the clay, for example, its the determination of CEC, and then titration curve of CEC, electrochemical properties of the clay, and then surface area of clay. These are the characterizations of the clay that used to teach in that courses.
Right. And sir, how was the uptake of that course? Like students were taking that course, and I am asking this because this kind of courses in education in universities or at research institute would motivate the next generation clay scientists.
Yes, that's right. It was taken by all the students, and they were happy with taking these courses, but not many students, because they thought it is a little bit difficult than the other aspects of soil science.
Yeah.
But people used to come, the students used to come and take these courses, and with interest they were taking part in the practical classes and the theoretical classes.
Yes. And sir, when you have been in active research until just a couple of years ago, before you retired from Indian Agricultural Research Institute, um, what was your latest interest in clay science in terms of agriculture or environmental application? What has been your most recent interest in clay science?
In fact, I started clay research in my MSc master program when I did worked on the electrochemical properties of clay. Then I
Mhm.
did work on the in the PhD also. Then I started clay work on in my research career as a scientist. I did work on several aspects of clay, for example, crystallinity, particle size of the mica by analyzing X-ray diffraction pattern, decomposition with detailed studies. Then I did work on the clay organic complex. And recently, which were very interesting, I felt that was on the nanoclay polymer composite. This is a
Mhm.
practical aspect. This is a making of a hybrid material,
Mm.
inorganic hybrid,
Yes.
reacting with the polymer, with the
Mm.
clay minerals, and making a structure which can be used as an absorbent of water as well as the nutrients.
Mhm.
And we tried to use that as a slow release fertilizer by loading fertilizers. So that was very interesting. And
Yeah.
still after my retirement, a group is still working on that same line in the
Mhm.
same laboratory.
Yeah.
So that was very interesting and to me.
Yeah. So that means, sir, you have started with the very fundamental aspect of clay science, and then you have touched through your research one of the most modern applied side of clay science, which is very, very fascinating. So, Dr. Datta, would you please tell me, like, among these various clay minerals, which is your most favorite clay mineral?
Oh, that is surely the Montmorillonite.
Yes.
Or in the group smectite group clay minerals because
Yeah.
of very high CEC, surface area, and very reactive. It can be
Yeah.
used for many purposes. That is
Yeah.
my favorite mineral, clay minerals.
Yeah. That makes sense. I think Montmorillonite is one of my, especially the 2 to 1 group clay minerals. I did my own PhD
Yes.
mostly on peligroskite. So yeah, they
Okay.
are very interesting materials. And these days, as you have mentioned, like starting from slow release fertilizer to various agrochemicals, this clay-based materials has so many different applications, and including nano clay. These days, people are working on. So let me also ask that in the clay science, what questions, what clay related questions you think still are remaining unanswered, and we should do, our generation or the upcoming generation should do more research on some of those aspects? Do you want to highlight any of the burning clay questions that needs immediate attention?
Yeah. Yes. Yes. That is very important. One of my students in the PhD, he worked on the clay phosphatase interactions.
Mhm.
And these two phosphatase enzyme were one was alkaline phosphatase, another was acid phosphatase. And so what the
Yeah.
data obtained, they showed that there are two different mechanisms for the acid phosphatase and the alkaline phosphatase interactions.
Right.
And that was very difficult to interpret. And so these things are very unknown, a unknown field.
Yes.
We can say the black area of the interactions between clay and the enzymes as well as the organic matter.
Yep.
And the most important study, as I feel, these days are the clay organic complex. Because
Hmm.
these are very practical implications with respect to the greenhouse gas emissions, carbon dioxide.
Yes.
So that area still many questions remained unanswered.
Yes.
And I feel more work should be done on that.
Yes, no, I fully agree with you. As you mentioned, clay and enzyme interactions, we have seen some very high impact research on clay biomolecule interactions in the medicine sector, or in human physiology field. But this clay and biomolecule, especially clay and enzyme interactions in the soil, that also has a huge implication, especially as we mentioned the phosphatase enzyme activity. So the phosphorus nutrition of plants has a big impact on plant growth and everything. So this is, I think, one of the very noble aspects of soil clay research areas. And you have also touched upon the challenges like global warming and greenhouse gases, and as you mentioned, the clay organic complex. So do you want to elaborate a little bit more on that, like what are the different other say broader picture global challenges that clay scientists can possibly try to address?
Yeah. You know, clay has a very important role for carbon sequestration. Everybody will agree with that.
Mhm.
It is only clay which is responsible for the carbon sequestration in the soil. They are the active part. In temperate region, they sequester more, and the tropical countries they sequester less.
Mhm.
And even though we have some explanation for this sequestration, but it's completely the mechanisms yet have to be recovered, yet to be explained. Difficult task,
Mhm.
because this is a natural phenomena, and it is very interesting also in the sense that, I once studied these thermodynamic properties of the soil organic matter,
Mhm.
uh, where you can see the organic matter has their own development in the
Mhm.
soil, and they interact with the clay minerals in such a way that the entropy decreases
Yeah.
in the soil organic matter, natural soil organic matter.
Yeah.
Although we know that this is spontaneous process, there is always increase in entropy.
Mhm.
And I searched literature, and most probably this is that dissipated structure, one of
Mhm.
the very highly debated topic.
Mhm.
One Nobel Prize, Laureate Prize also has been awarded on that dissipated structures. So the
Mhm.
natural organic matter also follows that same thing.
Yeah.
So it's a very deep thing we have to search on how that comes and how that interacts with the clay minerals.
Yeah.
And when they decompose, they give the carbon dioxide,
Yeah.
and which nature of organic matter will decompose early or decompose rapidly, which is not, that
Mhm.
still yet to be discovered or studied. So this
Yes.
is a fascinating subject,
Yep. Yep.
particularly with respect to thermodynamic point of view.
Yep. Yep. I fully agree with you. And yeah, and these days, some of the very um, recent or advanced analytical techniques, they can possibly be applied to understand some of these very fundamental mechanisms as well. Yeah.
Right.
Yeah, and I remember at our division of soil science and agricultural chemistry at IARI, we had a X-ray diffractometer, and you were the person who was operating that, and that machine, it is a very amazing machine, like is a old one, but it kind of speaks to you. The instrument used to speak to you. So it was very motivating and fascinating to all of us, all of as the students at that time.
Yes, you are right. That machine still works for 30 years,
Yeah.
continuously same machine.
Yeah.
And it is my effort. I was personally give a lot of time for that.
Yeah.
And no machine in this, I know what are the institutes. A machine can run only for 10 to 15 works, but it worked for
Yes.
30 years, 35 years.
Yeah.
And I took personally the care for that, all these things.
Yeah.
Uh, but so that is the thing. I also very much fascinated with that machine.
Yeah.
Several things I did on that.
Yeah. 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 So, Dr. Datta, I am aware that you have been involved with the Indian Society of Clay Minerals or Clay Mineral Society of India for many years. So, would you like to shed some light on the society, its activities, and everything?
Yes, I was attached that Criminal Society of India, who publishes their journal Clay Research from the beginning itself, 1981. I was a member
Right.
and then I became treasurer. And that
Right.
I remained treasurer for 15 years. Then I
Yeah.
remained secretary 10 years, then became
Mhm.
president. And throughout my career, I worked on the development of this or the uh, publications of the journal, Clay Research, as well as the running of the society. So that is
Right.
very a part and parcel of my life, you can say, to
Right.
develop
Right.
the society and the print journal.
Yes. Yeah. I think that is another significant contribution to you, to the clay scientist in India and people outside India. Yeah. And sir, being one of your students, I know, and I think many students will agree that you have been a fantastic mentor for students and early career researchers. So, would you like to give any particular message in regards to clay science or in this research direction to upcoming students and early career researchers?
Yes, of course. That's the thing which I could not do, that the early career scientist can do it, particularly the science, clay organic complexes and the uh, clay enzyme complexes that is still unsolved.
Yeah,
So they can start their work on that. And these are practical implications also these days,
yeah,
because organic matter, they supply both nutrients, they have to decompose. In the same same time, they have to be such that that carbon dioxide emission is not much. So this is a very problematic work.
yeah,
We want that decomposition of organic matter takes place, mineralization takes place, so that nutrient can be supplied. At the
yeah,
same time, it should not initiate the it should not enhance the global warming. So this is
yeah,
a very challenging job.
yeah,
I think early career scientists should start on that clay organic complexes.
yeah, yeah. No, definitely. I fully agree with you. Um, and in your research career, do you have any instance where you tried a particular experiment or regarding clay or clay science and that did not work well, and how you probably have handled it and solved the problem? Do you want to give an example to us as the junior researchers?
Yeah, I once started one work, the this effect of aging of clay minerals,
Mm-hmm.
kaolinite and montmorillonite. If you keep it side by side, what is
Yeah.
their effect? And started to do the X-ray analysis. What
Mm-hmm.
happens to that?
Yeah.
But probably lack of time or maybe I was busy somewhere, so I
Mm-hmm.
could not do that thing. Still, it is unsolved, and
Mm-hmm.
there will be some effect, the
Yeah.
aging effect of mixing of two clay minerals.
Yeah.
So maybe
Yeah.
that is another area which is
Yeah. No, I think this conversation, if any student or early career researcher, they are watching this video and wanting to know research ideas for their MSc or PhD thesis, they should pick this up and try to solve these problems, because these are really very important unanswered questions, and this can open up new research areas. So thank you very much, sir, for these inputs. Um, so uh, in terms of your research career, I know that it has been a profound teaching and research career for you, and one recognition is the Indian Council of Agricultural Research Best Teacher Award. I know that would be one of the very proud moment for you. Do you want to let us know any other proudest moment in your teaching and research career? Would you like to please share with us?
Yeah, very important. I spent a lot of time on the development of this my invention, the most important invention, that is soil test fertilizer recommendation meter.
Yeah.
Maybe 10, 15 years spent on that, on my research career from
Yeah.
the starting. And that is the one of the new kind of things in India, perhaps in world also, because this is a interactive type,
Mm-hmm.
and any layman can operate that thing because it's
Mm-hmm.
menu-driven type,
Yeah.
and it also can quantitatively analyze, because it is the combinations of electronics, C programming, as well as the soil chemistry. All the three
Yes.
things were combined in that
Yes.
invention.
Yeah. Yeah.
To spend a lot of time, and I have to read
Yes.
anything which is out of my arena, electronics and programming, everything I had to learn to
Yes.
develop these things. And there are so many obstacles were there, but ultimately I am happy and feel very pleasant that
No, indeed, a
my
great. Yes. Indeed, it is a great invention, and it is directly helping thousands of farmers in India, and it is a real important contribution. And when I was student of IARI, and even now, we all are very proud of you, sir. That uh, as you say, this is probably this invention these days will take researchers from 3 4 different disciplines, but you have been do it you have been you have done it like with your own effort single-handedly, which is awesome, which is really awesome. And thank you very much for this contribution to the
thank you.
soil science community, clay science community, and farmers especially. So we have discussed about research, about teaching. So let me move a little bit towards the lighter side of the chat. So would you please share also, like when you are not doing research or doing teaching, what is your favorite time pass and what you do for passing your time?
I play violin. I'm very fond of music.
Yes.
So I have a violin. So in leisure time, I play on that.
Yeah. I know. I think
But
I
very
have
little
been.
leisure time.
Yes. Yeah. And I had an opportunity to see you playing in a video on Facebook some time ago, and it's
Okay.
another creative side of yours. So and also, would you like to name one or two people who you think is your clay heroes? um, uh, in the past or present, who are eminent in clay science and whom you have been following or have followed?
Yeah. Definitely, I was a lot of respect for that person. That is Jackson, ML Jackson.
Yes.
I learned so many things from his
Yeah.
book,
Yeah.
and I had a lot of respect for him, and I
Yes.
follow him.
Yep. Yep. Absolutely. I think all of us, yeah, we follow Dr. Jackson's work. Yeah. So thank you, Dr. Datta. And I have been saying you, sir, because you have been my teacher, and it's an absolute pleasure to have this conversation with you. And thank you very much for your valuable time spending with me for this interview. And I also really appreciate your passion and dedication to this clay science research area, especially the soil clay mineralogy part. And thank you for making this outstanding contribution to clay science, and especially in Indian agricultural perspective. Um, um, this has been invaluable. And I think you have been an example for myself and many other students all over India. So thank you very much for that, sir. And your achievement and is also outstanding. Your as your huge contribution to the field of soil science, soil mineralogy, and clay science.
Thank you very much, and thanks for giving me a chance to interact with this criminal group by this video. I'm really thankful to you.
Thank you,
And
sir.
I also, as a teacher, I bless you, and God
Thank
bless
you.
you.
Thank you. Thank you, sir.